Hello, Hall Griffin here. Thank you so much for following up on our conversations in males. The goal of this quick PowerPoint is to do what I would do if I was sitting with you, go through the implants and components of the VetKISS microplating system, do my best to brief or organize you in terms of the learning curve. And what we won't be able to do with this presentation is put a set in your hands and let you practice. But at the end of the meeting, we'll talk about that one more time. Thanks again for being here, and I look forward to the rest of the presentation. VetKISS microplating system is a joint project of IMEX and Resystem AG in Switzerland. Resystem AG is the world leader in research implants, so think in terms of external fixators, locking plates, interlocking nails for research rodents, so things appropriate size for mice and rats. And I've really enjoyed the relationship with someone that understands miniaturization of orthopedic components. With the concept of small patients and small bones being the impetus for VetKISS, we were able to get cases and sets over to a variety of beta users. And as I pulled this slide, I realized I used all 1.0 sets and probably overgrabbed the small patients, but I think representative of long bone fracture repair seen with VetKISS. As other beta use cases came through, things that stood out to me that I had not anticipated VetKISS for, but make inherent sense. Arthrodesis in these toy breed patients. Of particular interest and ongoing use is the repair of multiple metacarpal and or metatarsal fractures using VetKISS, but in patients that you wouldn't think of a microplate in. Adjunct support of humerocondylar fracture repair, mandibular repair, and some maxillofacial work to date. And I really appreciate the additional feedback and comments from those users as well. The KISS acronym, I'm sure you've heard by now, keep it simple, surgeon. In the design and development, really stressed an economical system, and the economics should come, in this case, from modular instrumentation, i.e. one set of instruments will function with all three plate and screw sizes. Symmetrical plates, meaning no top or bottom, no right or left, and cut-to-length plates. It really means there's not a lot of implants you have to stock to make this system available and make it work across multiple different patients and bones. The VetKISS system is locking plate system, available in a 1.0, 1.4, and 1.6 millimeter sets, and that is just like any other plating system. Those dimensions represent the outer diameter of the thread, of the screw thread. Each plate's available in either a straight or a shaped, and the shape being a T on one end and an L on other, so you get both plates together. All of the implants for VetKISS are of 316 LVM implant steel, and that is an attempt to keep the profile of the plates and screws as small as possible. The locking mechanism of the VetKISS plates is different from most plates you might be used to. The plate holes are actually tapped to accept the entire length of the threaded portion of the screw. So in effect, you're threading the screw through the plate while placing the screw. And what that means, the screw can enter or exit either side of the plate. And regardless, once the screws are engaged with not only the plate, but with the bone, the locking system functions. And in this case, one can see threading the screw through the plate and can see screws having entered the plate from both directions. Hence, no right or left or no top or bottom to the plates, reduced plate inventory requirements. Regardless of plate shape, straight or TL plates, each plate is available in two general options. The R plate or rigid, I call it the real world plate. The day in and day out use plate is typically what you would expect. The other option is that of an X plate. If you look between the screw holes, you'll see this squarish, clover leafish cutout. That allows the plate to be contoured on the edge. It does result in somewhat of an intentionally weak plate that we classify as reconstruction plates, Quite honestly, they're rarely used with VetKISS, rarely with long bone fractures, but they are available as a reconstruction plate if necessary. The VetKISS screws are self-tapping. Regardless of the thread diameter, each screw is on a common 3mm removable but integrated drive shaft. That common drive shaft between screws means a single driver works across all the screw family. Interesting, the screw lengths as well as the plate sizes and shapes were developed in conjunction with some research or data collection at Texas A&M. We had a fortune of a veterinary student that worked in radiology take the time and effort to go in and review films of toy breeds, small dogs, cats, and even some exotics, populate spreadsheet data with that, and that gave us the feedback needed for plate lengths, screw lengths, etc. And that has been very beneficial. I believe since after that, beta use has only come up with a couple of other screw lengths beta users ask for. The finger driver is the first instrument we'll talk about. Finger drivers obviously is equivalent, the VetKISS equivalent of a screwdriver. So implanting screws, inserting screws, as well as removing screws. The finger driver holds 3mm shaft, which we just talked about was common to VetKISS screws. Also available is a short hex driver. It's also on a 3mm shaft, so it can go into the same finger driver. And if we look at a screw up close, one can see that the larger 3mm integrated drive shaft necks down just under or just outside of the head of the screw, and that's the primary snap-off location and typically what we expect. Again, the head is a hex. The outer hex gives one much easier grip application for removing implants, tightening implants with the hex driver, say as contrasted to a little internal hex broach or internal Torx type hexalobular fit, and very handy. Pre-drilling for VetKISS screws is required. One of the first drill options, or the first drill option we'll talk about, is the micro drill. It's an autoclavable electric drill that runs on common photo batteries. It is precision, it is delicate, it's very easy to orient the drill bit properly in harder bone scenarios or situations such as the larger drill bits. It can be power limiting. One of the keys is to remember to remove the batteries before steam sterilization. The quick couple method built into the micro drill requires these 1.5mm shaft micro drill bits. Each one is available in the proper VetKISS diameter, but in common is the 1.5mm shaft, and of note is the tapered end to that shaft. One of the things we really love about the micro drill is that it orients the drill bit in the same long axis as the drill, and that's the key to making it very easy to orient properly in the VetKISS plates, and very functional in that light. I'd like to play a short movie just showing how to load and unload the 1.5mm shaft drill bits into the micro drill. I think this will really speed up your learning curve or speed up your hands-on process when you do get a teaching set in your hands. Insertion of a 1.5mm shaft VetKISS drill bit into the micro drill. Note the cross pin off center in the drill. There's a corresponding taper on the drill bit, and the concept is to wedge that taper into the offset pin and feel that snug retention. To do that, one can visually line up the two and place that in, typically holding that. I felt it drop off, and I feel a resistance to drill bit attraction. Sometimes that feel is unclear, and what's easier to do perhaps is to intentionally put the drill bit in, orient it in properly. Stop rotation of the drill motor by your fingertip and just simply walk that around until it falls off further and you see and feel that longitudinal placement and lock. Okay, and at that point the drill is ready for use. Okay, then to extract the drill is simply to pull with enough force to remove the wedge, and the drill intentionally, if bogged down, can be removed by pulling the drill away from the drill bit. As the micro drill can be power limiting, especially as the drill bit diameters get larger, i.e. the 1.6 set, possibly the 1.4 VetKISS set, especially with dense bone scenarios, early VetKISS users ask IMEX to produce the same drill bit diameters except on a 2.35 millimeter round shaft. This is the common fitting for Hall air drills and other high-speed neuro burrs. Particularly, I like the Hall air drill because it does run lower RPMs with the variable speed control. Regardless, these air burrs hold the drill along the axis of the drill machine, just like the micro drill, so easy to maintain drill bit orientation. And if need be, either drill bit style can be used in a 3-jaw chuck. One just gives up that nice pencil-like orientation. Drilling technique with the VetKISS system is a freehand technique. It is reproducible, it is functional, and it's important to understand that the locking mechanism and just the size of these implants is not amenable to a drill guide. But let's watch the video and see how well that works.
After securing the plate into the proper position, pre-drill for the first screw insertion at the selected hole location. It is very important that the drill bit is perpendicular to the plate surface at the plate hole where drilling is occurring. Perform drilling with a pecking technique to avoid bogging or stopping the drill bit.
So visual observation of the drill bit in order to not drill off perpendicular happens in 2 planes. It is repeatable and reproducible. The single depth gauge works across all 3 VetKISS sets, so again, minimal instruments, and let's look at how that works.
Using the depth gauge, measure the hole depth, including plate thickness. The depth gauge is read on the outer end of the gauge body. Remember to add 1/2 to 1 millimeter to the measured screw length to account for the tapered cutting flutes at the screw tip. Here, we would select a 10 millimeter screw.
Screw insertion should be perpendicular to the plate surface, just like the drill bit process. The screws can angle a little bit, so it's not overly critical. It's important to verify that the screw enters the pre-drilled hole, especially if this is the first or second screw in the plate and possibly it slipped. And finally, screws can cross thread, yes, but that becomes quickly apparent. If in a turn or two, if things don't feel good, back out and repeat the process.
With the fracture stabilized with the bone plate and several screws, the screw shafts can now be removed. Using the hex head against the plate as a fulcrum and the finger driver as a lever, rock the shaft back and forth along the long axis of the plate to remove the temporary screw shaft. Alternatively, with the 1.0 and 1.4 millimeter screws, the screw can continue to be tightened using the finger driver until the shaft twists off of the screw head. A combination of turn and rock is also effective for shaft removal. When using the 1.6 implant set, the rock-off method is the only reliable shaft removal option.
The only other instruments needed to apply VetKISS plates and screws are plate cutters. As you know, these are cut-to-length plates, so a proper plate cutter is necessary to yield the plate length you want. And some sort of bending forceps. Our multifunction pliers are very nice to contour X plates on edge, but a pair of forceps of some sort is very good for contouring the traditional rigid plate in the normal plane. My biggest goal with this slide, or this series of slides, is to define the cause and prevention of insertion complications. That should really cut down the learning curve for VetKISS. And when I say insertion complications, I'm primarily speaking of premature failure of the integrated drive shaft, leaving the head of the screw away from the plate. By far the most common cause is poorly aligned pre-drilling that's not perpendicular to the plate in both planes. A second cause is that of just simply hard, dense bone, like you know, or in some patients in particular areas of bone. When those two are combined, the challenge is more severe. Look at the case below. It's a revision of a previous case, of a previous surgery. In spite of the bone plate being gently contoured to the anatomy of the patient, each screw seems to be perpendicular to the plate at the surface of insertion, and that's really the goal of the pre-drilling and proper screw placement with VetKISS. So contrast the previous case to this case. A quick observation of this case shows at least 1, 2, 3 screws that are definitely not perpendicular to the plate at their heads. If not more, and so it's 1, 2, perhaps 3 screws that are in place with the heads sheared off or non-existent. So as one applies screws and results in premature failure of the shaft, that's time to think about what's happening. And by that I mean, are we close, things were progressing and with slow loading, and therefore I can apply the hex driver and finish up that screw? Or are things worse, and therefore if I apply a hex driver and try to go forward, I'm simply going to shear the head of the screw off? And that's what I call the first decision time. And then the second decision time, if you fail a screw head, what to do is an example of this. And that is either take some forceps and remove that screw, replace it with a monocortical. To remove that screw, replace it or pre-drill, re-drill, and put a longer screw in, or perhaps to leave as is. I play the video to show and remind that the VetKISS system does not require the head of the screw to be against the plate or even a screw head to exist to lock. So it's not panic time in this scenario. It's realize things work, but at the same time, if you realize this is happening, you have an opportunity to make appropriate decisions going forward. Hard, dense bone, even with accurate pre-drilling, can present problems for premature drive shaft failure. And when this is recognized, there's a couple of options. One, to drive the screw with tapping action. It's a self-tapping screw, but using it like a tap, go in a turn or two, back off a little, in a turn or two, back off. That's proven effective. Others say when you have a known hard bone, it's advantageous to finish that drill hole initially, pull the drill bit out, clean the flutes, and go back in. And whether you want to use the term shave, ream, or just clean debris out of the pre-drilled hole, that can be beneficial. Most importantly, it goes back to that experience in developing tactile feedback, so you can understand when things are happening, when things are a little on the edge, and accordingly accommodate them. Occasionally I see users, surgeons in labs, in some videos where things are getting tough and they start pushing on the finger driver as you might push on a Steinman pin in a hand chuck. And again, the plates are threaded with the screws and they're mating, so pushing does absolutely nothing except flex the screw on the finger driver side of the plate and increases the likelihood of a premature failure. And I would say hard, dense bone cases are the places where the limitations of the micro drill show up. It can work. It will result in prolonged drilling times, and another drilling option may help you as well. Thank you again for watching. I'm going to give you my ideas to consider again. You've already heard those repeatedly, but I think I would like to repeat them again. First, tighten the screw head against the plate to contact only. Do not force. This is particularly relevant to the 1.6 millimeter screw, as such that if it's necessary later to remove that screw, it's not overly tight against the plate. First screw monocortical. This is an idea I've had pitched out by a few users. And the concept is that first screw is hard to get, the plate's wiggling around, maybe the forceps and assist aren't holding things still. So just go ahead and maybe pre-drill both cortices, but choose a short screw and get it in monocortical. It's kind of then a second pair of hands. And I would offer consider drill bits as initial first hand. So there's nothing wrong with getting a drill bit in, leaving it in the plate, taking another drill bit from the set, drilling a second hole, kind of like a temporary K-wire with some other plating systems. Rock along the axis of the plate to remove the integrated drive shaft. Again, position of several screws first, and yes, we know 1.0 and 1.4 screws work pretty well with torque off only or torque and rock, but it's a good habit. 1.6 millimeter screws, we've mentioned it prior and already here, rock off only, and again, that's because of potentially tightening the 1.6 screws to the degree that at a later screw removal time, they may be more difficult to remove, although certainly doable. The key take home is pay attention to the orientation of the drill bit and screws relative to the plate. This is the #1 learning curve scenario. Again, an occasional monocortical screw or headless screw are not dangerous, but will be vastly reduced in numbers with proper orientation of the drill bit in particular, and starting the screw as well. Again, monocortical, you can use them. Usual rules should apply. Thank you once again for taking the time to review this PowerPoint and listen yourselves through it and watch the videos. The video links I previously sent, if you haven't looked at them and would like to, the links are there. If you've got someone you'd like to share those links with at your practice, or even this video presentation for that matter, that's great with me. Be sure if I failed to cover anything or confused anything to contact me. We've chatted, we'll chat again. But there's email and phone number on this slide if you need it. I'm the point person at IMEX to handle loaning out and getting teaching sets into people's hands. And one of the things I'd like to do is make sure they've got this kind of fundamental, here are the nuances, here's what to watch for, here's how to repair it. That's complete as far as I'm concerned with you looking at this video, communicating with me and asking questions. I would love to work directly with you or a technician to get a teaching set in there, and usually I'll include a guaranteed purchase set with that, and we can talk about those details later. But have a lovely rest of the day or evening or whatever it is. I look forward to hearing from you soon. Thanks so much. Bye-bye.